Today we're going to finish our discussion about solving real-world problems in transformational form. So this is what we did yesterday. I wanted to show you guys where we got this 10 minus x from. I didn't think it was appropriate yesterday. But if you remember, this problem was maximizing the area with a perimeter of 20. Talking about a perimeter of 20. So if you have a perimeter of 20, do you guys see that the least number of length would be 1, right? And the highest number of length would be 9, which makes complete sense because if you're talking about a perimeter of 20, if this was 10, right, then this side would be 10, and that would be 20, and this side would be 0. Does that make sense? Like this is the most this side could be, but we can't have a side of 10 and 0 because then we wouldn't have a rectangle. It would be flat, right? So that's where this number comes from. You've got 10 minus however much the other side is. So the smallest number this side could be would be 1, right? The smallest size it could be would be 1, and therefore 10 minus 1 is 9. Do you guys see how that works? And which is exactly what we had here. The largest side we could have would be 9. The smallest side we would have is 1. So let's talk about if you had a maximum, let's see, a perimeter of 26. Perimeter of 26. It would be x, and what would this be? 13 minus x. Because you cut 26 in half, and 13 is your maximum number, right? Because you're splitting them. Okay, so I just wanted to clear that up. It's not something that you're going to be tested on, but I wanted you to know where it came from. It didn't just pop up out of anywhere, okay? All right, so this one we looked at yesterday, right? Let's look at it briefly. Good morning. Okay. So write an equation to find the area of the right triangle and then determine the maximum area. Okay, so let's see what you guys remember from yesterday. So what is the area of that triangle? Write it down on your whiteboard. Just the formula. I want the area formula for a triangle. Quickly, this should be reviewed from yesterday. I just want the area formula. I don't want you guys to substitute anything in. And I want you to show me, everybody, in 3, 2, 1. All right. We're good. Okay. So, just like we talked about yesterday, the area of a rectangle is base times height, but we're talking about a triangle, so we cut it in half, and so it's half of the base times the height. Well, we do have the base and the height here, correct? So our base was 8 minus x, and our height was x, correct? Yes. You want a different marker? Yes. Another one as well? Here, I'll trade you. Are you good?
Yes.
Okay, but part of the problem is you've got that uncapped right now, right? Yes. I am. You want to trade? Okay. So we're going to maximize area, right? I'm going to draw myself a little graph over here. Remind me, what were we maximizing on Tuesday? Was it Tuesday? We're maximizing revenue. So was revenue the x-axis or the y-axis? How can it be both? It was the y, right? Because we were talking about how many times we're going to decrease something, and that's going to affect how much the maximum revenue is. So this isn't going to be maximum revenue. This is going to be maximum area, right? And it's going to depend on this side of the graph. Correct? So let's change this area to a y. Now I know we looked at this yesterday, correct? I think I just want you to struggle with this for a second. Remind me, what form are we trying to get something into? Transformational form. So start trying to manipulate that in your table groups and try and get it into transformational form so that we can manipulate it. Okay, I'm going to come around and guide you. Okay? Okay, so the first thing I want to do to get it into transformational form, remember our transformational form is our 4p times y minus k. I'm going to write it over here on the board. That way we have it, because then I'm going to have to write it on every screen. So we have 4p y minus k equals x minus h squared. So that 4p is how wide my parabola is, correct? Well, right now, it's over here. It needs to go over here. So I'm going to multiply everybody by 2. And remember, Aaron, this is multiplication, so it's all attached, right? This is all attached right now. This is saying half of a quantity times a quantity. So we don't have to worry about anything right here. We just have to worry about this. So that cancels the 2, and I'm left with 2y equals 8 minus x times x. So if you didn't do that part, you need to do that part first. Can't find the vertex from that, right? So we need another strategy. I'm going to have to FOIL this. So x times 8 is 8x, and x times x is negative x squared. I might as well move some stuff around. 2y equals negative x squared plus 8x. Now, are we on the right track now? Okay, what's something that I still need to do before I can complete the square? That's not negative. No, it's just switching places. It's just switching places. Yeah, no need to make it a negative. Okay, so I'm going to have to pull a negative out of everybody, right? Since there's an addition sign here, it's going to affect this one too. So when I multiply everybody by -1, we're going to turn this into negative 2y equals x squared minus 8x. Can you go from there? Keep going. 1. All right, let's finish this up. Okay, so the next thing I need to do is I need to add something to both sides to complete the square. When I do that, what I'm going to add is half of 8 is 4, so negative 4 squared. Negative 4 squared is 16, positive 16. When we square anything, it's going to be positive. So this on this side is negative 2y plus 16. And on this side, we have a perfect square binomial that's x minus 4 squared. Then I pull a negative 2 out on this side, and I get y minus 8 equals x minus 4 squared. So When I look at my vertex, I get 4, 8. Let's make sense of that now. When the side, what were we talking about originally? When the side of the rectangle is 4, right? What's the other side going to be? Let's look. What's the other side going to be? If one side is 4, the other side's going to be 4, right? Because 8 minus 4 is 4, right? Okay, so when one side is 4, what's the maximum area? Why did that not work out correctly? It should be 16. Why is it saying 8? Because it's half. Thank you. Because it's half. Which makes sense, right? So when our side is 4, when our side equals 4, our maximum area is going to be 8, because this is 4, 8. And just as Malik did, he needs a piece of candy for that one. We said, well, if the side is 4 and 4, then this area would be 16, but it's a triangle, so it's cut in half, so it's 8. Make sense? Okay. So these are the most challenging ones because you really have to do some work on these, right? You've got to manipulate the whole equation to put it into vertex form. So let's do something that's a little bit more straightforward. It doesn't look straightforward, but it actually is very straightforward. You should be able to look at that equation right there and tell me, Mrs. Mahler, this is easy. Why? Okay, so everybody's talking at once. Kane. You don't want to get rid of the decimal point. You could, but you don't need to. What do we have up there? Don't even look at the words. Look at the equation. You have to subtract 11 from both sides. So now we have y minus 11 equals negative 0. This crazy decimal times x minus 20 squared. But what do I look? I'm not even reading the problem. What can I make sense of this? Yes, I already have the vertex. What's the vertex? 20, 11. Without even reading the problem, I already have pieces of information. Bryce, I need you to stop talking. Without even reading the problem, I already have pieces of information just by looking at that equation and knowing how I can manipulate it and find a vertex. So I already know a maximum. I know this is my max. Max. And what's this? It's my axis of symmetry. Right? It's my axis of symmetry. The 20 is the axis of symmetry, right? Because you go over an x and you go up to y. That's your highest point. Your highest point's always going to be on the axis of symmetry. So I already have pieces of information without even reading that big old long word problem. Right? So it's not scary. We already know a lot. Okay, so let's figure this out. Let's go back and look at it. So a football team needs one more goal to win the game. The goal post is 10 feet or about 3.3 yards, which I've drawn a picture for you. 3.3 yards. That's how high the goal post is right there. The pass of the football after it's kicked for a 35-yard field goal. So out 35 yards is that field goal right there. Correct? 35 yards out. What do we know about yardage already? Okay. We know more than that from what we've already gathered, the information we've gathered. That's 35 yards to here, right? You've got a parabola, 35 yards, right? We don't know which one it is yet. We're guessing. What else do we have from this? What do we have? We have the vertex, exactly. You can kind of find what? The axis of, I already know the axis of symmetry. Where's the axis of symmetry? At 20. So we'll say, like, if this is 35, let's just pretend this is about 20 right here. I'm going to say right here. This is 20. Why doesn't it make any sense? Or can we pretend, guys, it's a sketch. It's something I pulled off the internet. Can we please not pick it apart? All right? No, you don't. You don't want the highest point to be worth. Guys, it's a picture. It's a rough draft. You guys need to stop nitpicking. Seriously. Do you want me to draw a whole new picture? I can. Are we bothered by this picture? I'm getting irritated. Here's a goalpost. This point right here is 35 yards. We don't know. Question mark. We don't know whether or not it's going to go over that goalpost. We do, however, know that our highest point is at x equals 20. And what does y equal? 11. So 11 yards up is right there. So that's the picture I have just based on the information that I've given. Okay? Does everybody see that? Okay. All right. So let's look at what we've got. So it says where x is the distance traveled and f of x is the height. Does the team win? What was the maximum height of the ball? So does the team win, and what's the maximum height of the ball? Which piece of information do I already know? The maximum height. So our maximum height max height is 11 yards. I wonder how I'm going to figure out what the height of the ball is at 35 yards. Think about that for a second. Here's my equation. Where do I want to put it? I don't have it on this one. That's weird. I'm going to copy and paste it. Okay, so here it is. There's a way to find the height when the yards are 35. How would I do it? I'm going to plug in 35, right? I'm going to find out how high it is by plugging in 35 to x, because this is my x-axis, right? So I know that this is where x equals 35. So let's find out what y equals when x is 35. So I have y minus 11 equals negative. You're going to need a calculator for this one, right? 125 times 35 minus 20 . 35 minus 20 squared. Work out with your groups. Everybody should have a calculator. Everybody should be trying to enter this into their calculator and figuring it out. I'll give you guys about a minute. Okay, so unfortunately I forgot to record on this one, but what we decided was that since we knew that our vertex was at 20, 11, our maximum height was 11, and then we plugged in 35 because we want to know how high the football was going to be at 35 yards, and so we substituted in 35 into our equation, and we got several answers, but we found out that the answer was 8.2. And since the field goal was only 3.3 yards off the ground, we said yes, they made their field goal. All right, so let's go to this one now. So the first thing I'm going to do immediately is I'm going to manipulate that equation to say y minus 7 equals negative 0.0175 minus 20 squared. Alrighty, so I know that my vertex is at 27. That means at the highest point of this ball being thrown in the air, it's at 20 and 7 feet high. Let's read the problem. When a ball is thrown into the air, the path the ball travels is modeled by the parabola, so-and-so, measured in feet, where x is the distance traveled and y is the height. Distance traveled, height. What is the maximum height the ball reaches? What's the maximum height, guys? 7 feet. Right? It's over 20 and up 7. We're 7 feet up in the air. How far does the ball travel before it hits the ground? Well, if this is halfway, right, then what's this going to be? It travels 40 feet. You didn't even need anything other than making sense of the problem. Are these actually that hard? No, you just have to make sense of the information that you're given. You guys ready for another one? Yes. That is not enough work. Yes. It's usually going to be a no for you, Kane, right? When in doubt, show more work. Okay. A parabolic microphone or parabolic microphones are often used on the sidelines during football games. Look at all these football themes, right? The cross-section is modeled by the equation negative 36x equals y squared. I'm going to immediately manipulate that. Negative 36, what's x going to have with it? A 0 equals, what's y going to have with it? A 0 squared. Let's visualize that. I'm visualizing, we're at 0, 0, right? My vertex is at 0, 0. How wide is, I'm guessing right now, right? I don't have, we know that it's negative, so it's going to be going like this, correct? We know there's going to be a focus and a directrix. I just don't know quite how far it is. But here, I know this is 36 wide. Give me 1 second, guys, 30 seconds. If this is 36 wide, how far is P? How do I know it's 9? Because 36 divided by 4 is 9. So it asks us, how far is the receiver from the vertex of the cross-section? It's 9. Would it be feet? What are we measuring in? I don't even know. How are we doing? Good? Yes, sir. Yes, please come after school today.